Hey everyone, and welcome at Global AI Generate. We're very happy that you could join us again today. We're looking forward to quite some new contents. What are you looking forward specifically?
I'm looking forward to learn all about generative AI because I completely missed all the announcement in the last couple of months. No, just kidding.
I was already wondering how is that possible?
Yeah. No, I'm really looking forward to it.
But you know what ChatGPT is, right?
Yeah, I've heard about it,
Okay.
but I'm not completely sure what it is. Hopefully, I will learn something about it
Wow.
during this event. No.
You will do,
Yeah,
for
yeah,
sure.
yeah.
Well, we're having quite some nice content that all of you can watch. We'll have a keynote that we've recorded at the Microsoft campus where we invited some leaders of the Microsoft AI department. Looking forward to learn about their thoughts about what is coming, the dangers also how we can use AI within education. And then we also have some other interviews.
Yeah, we have an interview from you with David, right? About all the capabilities and the possibilities of OpenAI. And next one is Beatrice, who really going to clearly explain us how large language models work. And then we're going to shift to the studio with some live sessions.
Yeah, so we're gonna have two nice live sessions from Werem and Alessandro. Then at the end, we'll have a discussion with all of them together and another extra panel member. So stay tuned and learn more about generative AI.
Yeah, and you can also participate during the event by dropping your questions in the chat window. And we will also ask our panelists and our presenters those questions as well. So let's start with the keynote.
Exactly. Let's kick off.
Enjoy.
Sit down and enjoy.
What would you do if I just didn't complete this? So in your head, you completed my sentence, right? You probably said sentence or statement, something in your head completed what I was going to say. And that's basically how generative AI actually works, is that it really learns to sort of complete the next most likely word by word at a time.
Concept of generative AI, I would say the difference between a traditional AI model and a generative AI model is that the traditional model is built to perform a particular task. So you build a classification model to, really address a classification task. So it's very, I would say, vertically kind of like developed. But if you want to do several things at the same time, so if you want to summarize and you want to extract the sentiment of a conversation or a body of text, and you want to generate an email out of that, then generative AI models are better suited for that. So generative AI models have been built on a large corpus of data, and they have trained themselves to actually perform multiple tasks at high capacity. So they can do a lot of different tasks, like as I said, content generation, summarization. They can generate code from natural language. They can do knowledge mining. So they can be much more powerful than the traditional ones. But also another thing to keep in mind is that not all use cases should be addressed through these generative AI models. I think that's a common misconception, that they're so powerful and they can solve every use case that we have, which is not the case. I think we have to start with what are we solving for, what is the scenario that we really want to optimize or automate, and then pick the right AI model for the task.
A foundation model is a large model that has been trained not just to perform a very specific task, but rather it has been kind of built so that it's the kind of the foundational element, the key building block for many tasks that it can be applied to. So we see them today with models like GPT, where the model itself, it's while there are some objectives we use to actually train the model, the nature of the model is such that the task used for training is not that important from the usage standpoint. These models then get used for things like summarization or classification or content generation. And in the end, they're the same underlying model. Sometimes they're fine-tuned, sometimes not even that. They're just kind of few-shot prompted. So I think, I think the industry kind of looked for a term for a while. We sometimes hear large language models, sometimes we hear foundational models. These things will go into, they'll go past text. They're already going past text. So we need a name. Maybe large language models was good at some point, but maybe we need a new name. And it's been a while since foundational models and a write-up that went with that went out, and it may be the name to use.
There's a guy named Andre Karpathy, and he used to run AI at Tesla, and he does something else now, but he said something that kind of stuck with me. He said, the hottest new programming language is English. And so the way that you program these things like GPT is by using natural language like English. It doesn't have to be English, it can be other languages, but it's not a programming language as you normally think of it. So prompt engineering is the art of using this kind of natural language to get the results you're looking for from the model.
Turns out that when we all first get in touch with these models, we try the simple things, complete the sentence, summarize this text, and they all look reasonable. But as the tasks get more complicated or as the input gets more open-ended, you want to make sure that you give proper instruction to the model. Sometimes you want to also enforce certain formats of inputs or outputs or a certain interaction style. And prompt engineering is this whole practice of how do you construct these prompts, what are the sort of kind of tools and patterns available to you in order to get the system to or the model to do what you want, and also how to then, when you have a starting point of a prompt, how to then go from there into what is the right way to iterate and maybe even sweep over like a set of slightly different prompts, validate which ones are doing better, and then once you shipped, maybe one iteration of the app with this, then how do you know that the next iteration doesn't regress? So all of that has to do with, in the past we would have done that with code and unit tests. I guess we're in a new world, and now some of these things you need to explain to the thing in English, and there is a structure that needs to kind of emerge around this, and I think prompt engineering covers that kind of overall problem space.
Imagine for a second that you're trying to learn something new. Maybe you are in elementary school or high school. There's a new concept you are struggling with, and there's something that can help you on the way. You can ask questions. It can explain things to you. This is the opportunity we have in our hands. The other beautiful opportunity in the education system is that all of these we call co-pilots, these assistive agents, can personalize to you, can learn about how you learn. We all recognize that there are differences in the way we learn, and now these agents can personalize these experiences to us. That's what is so exciting about them.
I really think that generative AI has the potential to support knowledge workers, information workers, to deliver that first rough draft of something, to get us, and I really am thinking of how it helps me in my work in being able to deliver and get me unstuck sometimes when I'm trying to figure out how to get started.
In the context of business landscape, all these large language models are going to push on both of the fronts you would look for. First, for things we already do, it'll make us faster, more effective, more productive on accomplishing what we need to accomplish on tasks that we already understand. But it will also let us go for things that we maybe would have not tackled today. So I think we can be curious about going and searching for things that maybe as a business we wish we could do, but maybe we didn't have the right tools in the past. And I fully expect a whole bunch of disruption emerging out of these tools being broadly available for businesses to go use and put to work on their own problem domains.
The reality is that yes, AI might replace some jobs that they were probably low-paying jobs, they were repetitive jobs, they were jobs that didn't really require any critical thinking. or complicated tasks that a human brain does. But at the same time, we're going to see the proliferation of net new jobs that require knowledge of AI across multiple industries. So, for example, in healthcare, it's going to be really a great tool for a physician or a radiologist that they want to really interpret an X-ray, or it will be a great tool for someone in manufacturing that want to expedite kind of like, repetitive tasks. It will be also a great way for educators to really create more personalized lesson plans for their students.
Where it's going to start is in search engines like Bing. So certainly that has taken off in a big way. And in assistive coding environments like GitHub Copilot. And so already you see these kinds of large language models taking off there. I think we're going to see them more and more in all kinds of other software applications that we use today. And so here at Microsoft, of course, you're going to see it in things like Teams and Dynamics and Office. And it's going to show up in all of these different places to kind of help you do what you do. So I think that's going to be a thing. Over the long term, longer term, I think it's going to start to show up in the real world. I think that we're going to start to see assistive technologies that can actually take actions for us, that they'll start to be able to first order a pizza for us, and then maybe later on they'll be able to clean up a spill if you spill your Coke on the floor or something like that. So that's coming.
We see AI being a great tool to automate a lot of the tasks. We see that also with the retail space, the idea of further personalizing the experience of a shopper. And in healthcare, it's a great way, again, to personalize health kind of like scenarios, and also give physicians and healthcare providers greater tools so that they can do their work better, faster, easier, and more accurately. And in general, I think AI tools can really provide, automate a lot of mundane tasks and allow humans to actually spend more time doing what they're great doing, which requires a lot of critical thinking, creativity, so ultimately increasing the productivity of these individuals.
If I make an image with something like DALL-E or Stable Diffusion that is an Andy Warhol painting that never existed, who owns the copyright to that? Do I own it? Does Andy Warhol own it? Because he didn't make that either.
It is very clear that a lot of power of these models come from the data that they are trained in. As Microsoft, we are careful about where this data comes from and be able to track the source of the data that we are using. At the same time, we also recognize that as generative AI becomes more and more powerful, we will need to think about new set of rules and regulations that can really govern our relationship with data. This is why some of these problems have to be an industry size discussions, and then we have to engage with other companies and lawmakers and the NGOs to be able to make the right decisions when it comes to data and our use of the data.
I think that the future of this AI technology, the importance of this next generation of AI, generative AI, is really important to consider the potential for the benefits, and also think about how we can safeguard and protect people, organizations, and society from the potential ways it could be misused. That's really important and part of what I'm so proud of the work that Microsoft does in this space.
Responsible AI is at the core of how we build AI systems in this company and also how we deploy them. Microsoft has been a leader in the responsible AI space from the beginning. We have a whole ecosystem in this company, including the work I and my colleagues do in the research space, to the product teams that we work with, and also the legal teams we work with that support our work. And it is very important to be principled in our approach to responsible AI. So the way we approach this problem is that from the design stages of the AI systems we build, we think about responsible AI, we think about our responsible AI principles, we think about the potential impact of our systems on the world. And then we follow careful processes in place with our responsible AI standard to think about measurement and mitigation. At the same time, we recognize that all of the issues we are facing in the responsible AI space, it will be an ongoing process. We will be learning from deploying these systems into the world and observe the impact they are creating, and then revise our mitigations and continuously work towards creating applications and processes that can do this better and better.
I guess I have two answers to what's next for generative AI. The first one, who knows? I mean, at the speed this is happening, I think if we've shown one thing is that this kind of much faster than linear progress that we're seeing doesn't seem to be stopping. But maybe a more concrete point on this is, I think we'll see applicability. For now, I think we're in the kind of fascination stage where early adopters are starting to apply it, but in the more broader sense, we're still all trying to figure out what's the best way to put this technology to work, and what are the best scenarios, both existing and new, where this can play a role. I think while there will continue to be progress, of course, on the bleeding edge, I think applicability of this technology is going to be a fascinating space. We'll see all these creative ideas materializing on real new types of applications.
Well, that were some very interesting thoughts that we received from these nice people. Now, I think if we had a look at this, we see there's quite some inspirational cases that they already brought.
Yes.
But I think it was nice what Pablo also said, that now it's time to bring stuff, make it applicable.
Yeah.
But I think to be able to make use of this technology, you also need to start understanding what it actually does, right? How it works.
I totally agree.
Yeah.
And once you actually know what is going on, you can be so creative with building new applications around it, embedded it in your productivity tools or your daily lives. And I'm really looking forward to that.
Yeah. And that's what our next session is going to bring. We had a nice interview with David, and David is going to explain us a little bit more about foundation models. Hi, we're here together with David, and we're going to talk a little bit more about Azure OpenAI. Hey, David.
Hi, Sammy. Welcome.
Welcome you to the show.
Thank you.
David, can you please introduce yourself? Who are you?
Yeah, my name is David Smith, and I'm with the Cloud Advocacy team at Microsoft. We're developer relations for the artificial intelligence and machine learning community.
Okay. Now, David, we want to talk today about Azure OpenAI. So let's start a little bit with the foundation.
Mm-hmm.
And that brings us also to foundation models.
Yeah.
Can you please explain a little bit about what that is?
Okay. I mean, this is really in the context of these large language models, at least. This is a brand new thing of having a way to have computers understand natural language text written in English and other languages, and also on the generative side to produce natural language text in a way that computers have never really been able to do before. And not only can they generate that text, they can do it in response to prompts. So they can answer questions, they can generate new text for marketing campaigns, they can write stories and poems. And it's all a very new and exciting area. I've been working with OpenAI since it first sort of came on the scene, 6, 7, 8 months ago? And things just changed so quickly.
Yeah, it's going very, very fast.
Yeah.
It's hard to keep up with all the new developments that
Absolutely.
are there.
Yeah.
Now, within OpenAI, is there just one model, or are there multiple, or how does it work?
Well, it's gone through a whole history.
Mm-hmm.
The model that people are probably most familiar with is GPT. Some of the newer versions that are available now are GPT-3, which is probably the one that got the sort of the first mainstream attraction. It's a language model that you can ask questions of and gives great responses most of the time. OpenAI, the company, then enhanced that to become GPT 3.5. And then they also introduced a chat version of that model. They gave it some additional training with some additional data about some conversation, so it could produce responses in a much more conversational tone. And also for the first time, they introduced a human element of actually rating the responses that ChatGPT gave to a whole series of questions, and used that to further fine-tune and improve the GPT 3.5 model as ChatGPT. And that then was released as a consumer product, 3-4 months ago, and was the fastest growing consumer product in history. It was like 1 million users in the first couple of weeks, and now 100 million users. It's unbelievable. The latest model, which just came out a couple of months ago, is GPT-4, which really takes it to the next level in terms of understanding, in terms of generating text, and now even in terms of perhaps even doing reasoning on concepts and producing responses to those as well.
Okay. Well, that's purely on text.
Exactly.
Is there anything else also?
Yeah, absolutely. We'll talk about the way these models are trained, but if you train them on different corpuses of data, they can specialize for different kinds of tasks. And so another model that OpenAI produced is called Codex. And then rather than training on it essentially all the text in the internet, they trained it on all of the code, the open source code in GitHub. And that model is, as you might expect, very good at generating code either as completions or extensions of prompts that people give it, typically through a user interface, or even generating entire functions or even entire programs based on the training data that came from that GitHub repository. Moving on to images, you can also train these models on a very large corpus of image data associated with labels, descriptions of those images. You might think there are captions that exist with a whole suite of images in all sorts of domains. And then you can go backwards. You can go from the caption back to generating an image that would represent that caption. And the most famous model for that, of course, is DALL-E.
Well, it's very impressive, all the technology that is there.
Mm-hmm.
But can you please help us a little bit understand how do these models actually work?
It's difficult. I mean, fundamentally behind the scenes, it is a very, very large neural network. And let's focus just on the text side for a minute. Now, most of us have experienced ChatGPT through its chat interface. You ask it a question, perhaps, and then it gives an answer as its response. But behind the scenes, it's doing something very, very simple. It's taking a sequence of tokens. You might think of these as just words, is a very rough simplification. We can get into the difference between tokens and words later on if you want. But if you give it a sequence of words, these models, the one and only job for these models is to predict what is the most likely word to follow the sequence of words you gave it as its input. And it does that by basing it on what it has seen in its training data. If you have lots and lots of examples of, I climbed the tree and picked an apple, if you give it the prompt of, I climbed the tree, the word it's likely to respond with is an apple. But another interesting thing about these models is that they're deterministic. It doesn't just predict one word. It actually takes all the possible words that it might respond with and gives it a probability. And then it samples from that probability distribution to generate the next word. So what that means is every time you run the program of, given this prompt, give me a response, you might get a different answer every time you run it. And that makes it a very different computing paradigm, which is something we can dive into.
Yeah, so some people, when they talk to ChatGPT, they might think the AI is emotional, or it can show emotions.
Yeah.
But if it's purely with numbers, there's no emotions at all, right?
Yeah, there's no person behind it. This is really, at the end of the day, it's matrix algebra on a very, very large matrix, which is the neural network that sits inside these models. But I think this response that people have of like, it seems like it's being emotional is because the language it produces is so natural. because it's been trained on such a large volume of English text and text in all sorts of languages, that it seems like there's a person behind it. But I really want to emphasize that this is just a mechanistic process of multiplying some numbers together to predict what is the next most likely word in a sequence.
Okay, I think that's good for the public, for people who really don't exactly know how AI works, that they at least understand that and they get that there's no emotions at all at the end. It's just math at the end.
Yeah, and not just no emotions, there's also no sense of what is a fact. There's also no sense of, what is a polite way or an ethical way of responding to something. It is really just predict the next word and nothing else.
Now, these models, they predict words, but is there some way to fine-tune what the output is of those words?
There absolutely is. And let's go step back a bit and think about, reasons why you might want to fine-tune one of these models. Because first of all, the models are trained, in the case of the GPT models, on essentially the entire internet. And think about what that means. Yes, it has, all of factual knowledge from Wikipedia. It has all of scientific knowledge from Archive. It has literature from Project Gutenberg and, thousands of other sort of authoritative sites where it can find examples of text and, sources of information. But think of the fact that it also includes, every blog that's out there by anybody who might be writing blogs. It includes, comments from social media sites. It includes, just any random text that it might crawl across the internet. And think about what that might mean in terms of if you prompt it with, something that is, from about gaming. There's probably lots of gaming sites out there, and it might respond, an answer about Zelda or, Mario or things like that. You might not want to have that kind of response in a business context. And so you might want to do something with those models to make them behave less generally than they would over the entire internet. Now, fine-tuning is one possibility with that, but I would actually look towards prompt engineering before you go to fine-tuning them.
Well, that might bring me to the next question. Yeah. What is prompt engineering?
That's a really good question. Now, most of us, our experience with ChatGPT, again, is just with that textual interface. You type a question, a couple of seconds pass, and then it starts spitting out a response in a text box underneath that. But what's happening behind the scenes there is actually a little bit more complicated. First of all, we mentioned words and tokens earlier on. It's actually generating that response word by word, or in fact, token by token. And it's kind of recycling one word back into that prompt, regenerating the next word, cycling that back into the prompt, and on and on and on. Now, the trick is you can actually put more information ahead of the text that you type in that box. You could, for example, behind the scenes in a ChatGPT interface, inject at the front of the prompt, respond in the style of Marvin, the paranoid android from Hitchhiker's Guide to the Galaxy. And then when you ask it a question, it will then start responding and saying, like, I'm so sad, like, I've got a brain the size of the universe, but, I will respond to your question and tell you these kinds of things. So as programmers building applications, we have a lot of flexibility in providing not just what the user entered in the chat box, but lots of additional context ahead of that. And we call that the meta prompt, the combination of what we provide as programmers with what the user provides in the text box. And I gave the example of giving some guidance in terms of the personality of the style of the response. But you can also use that meta prompt to provide grounding to the artificial intelligence model. You can give it information if you're, for example, a consumer chatbot for a retail store. You can provide information about what your store does and what your products are. You can give it some guidance about, say, don't respond anything if the question is not about clothes. And we've learned over time that when you put those kinds of grounding into the prompts, that the GPT models do indeed, follow that direction most of the time, at least, with respect to the way people respond. So we're finding now that the way that we can control these GPT models is by providing lots of information, that meta prompt, that additional part of the prompt that the user doesn't see. And we're learning more and more about how we can even provide commands to the GPT models through that meta prompt to control how it responds and how it doesn't respond when users interact with it through a text interface.
Okay. Well, as you said already before, ChatGPT is the growth of the amount of users went like skyrocketing up. What do you think will be the next phase of all this technology?
That's a really good question, and honestly, I have no idea. I mean, you could ask me this question next week, and I'll give you a completely different answer because things are moving that fast. But I think the really interesting things that I'm seeing right now, and especially having conversations with a lot of the Microsoft MVPs that I've been chatting with just this week, is that we're going to see an amalgamation of not just these GPT models, but other services as well. I was just having this conversation, in fact, that, you know, GPT models, they're great at creating words and sentences and coherent English. They're not really great at generating facts super reliably. And they're even worse at generating lots of facts at once. And if you think about a situation like, you know, you're a clothing retailer and somebody in a chat experience is saying, like, give me the list of all your products, you know, by size and their current price, something like that. So it's the response would be a big table. Now, a GPT model would happily spit out a table, but the question of whether all the entries in that table are correct is, you know, it's a little bit questionable. But we're seeing some models now where through some of these agent-based systems, you can actually direct a GPT model to then say, okay, this is a question that requires some access to a database, for example. Go out, write a SQL query, run that against the database, and then rather than the GPT model generating the text of the table, just grab it straight from the database and embed it as a, you know, an Excel sheet or whatever in the response. So it's combining the GPT models as a really good framework for, first of all, interpreting questions and generating the English or any language context around those questions, but then going out to other services to fill in the factual information or any other sort of pieces that you want to put into the response. It doesn't have to all come from GPT.
So it's really up to the people now how I'm going to combine this technology with my own software that I've maybe built and see what extra help I can give to my customers.
I think that's exactly correct, yeah.
Okay, cool. Now, one more thing that people also might ask, like this Azure OpenAI, their API endpoints.
Yeah.
Is there any way I can just put them on my own servers or in containers or anything?
Not today, at least. So the thing about these models is they're, number one, very, very large and very computationally intensive. You really, at this moment, do need a data center to be able to run, especially something like GPT today. You know, I do think that is going to change over time. I think we're already seeing that, you know, the GPT-4 model, OpenAI hasn't announced, you know, exactly how many parameters as it is. But I think that how many parameters it has in the model. But I think we're definitely seeing that improvements in the future are going to come not with making bigger and bigger models trained on more and more data, but understanding better the process of refining smaller models through things like reinforcement learning with human feedback, you know, actually providing some feedback to these models and then doing that fine tuning before we release them out to the wider world to use.
Well, with the speed of technology, things might change so fast. So
I think that who knows what's going to happen in the next month, right?
Indeed.
Yeah.
David, thank you very much for your time. It's a very interesting conversation. And we're looking forward to everything else that is coming.
It's been my great pleasure, and this is such an exciting space to be in right now.
Exactly.
Yeah.
Well, I think this was already a good overview of what foundation models are and what they can do.
Yes, definitely. That was a real good interview you did together with David.
You understand it now, Shokje?
Yeah, I understand it much better now, yeah. And what I really, really liked about it is how he told us how we can ensure that that model is grounded, that the responses that we get are more fact-based.
Yeah, like the example how we get some data out of the SQL database and consume that. There's so many different applications and how to make it better.
Yeah.
Now, we have those GPT models. Now, let's have a little look in how they more work. What are tokens and so on?
Yeah.
Right.
Let's do that. Let's go to our next interview.
Could be, yeah.
Yeah, or our next session, actually. Yeah.
About how the GPT models work. But before we get that, let's talk about how general generative models work. So at the very high level, the way they work is that they get n tokens in and they produce 1 token out. So this is a very simple idea if you know what a token is. So let's find out what a token is. So in the case of OpenAI, a token is really a short sequence of letters. So for example, a token can be a whole word, for example, the word we or need, because those words are short and they're very commonly used. But a token can also be a part of a word. So for example, the word anthropomorphize takes 3 tokens because it's a very long word that is not very commonly used. And so this is just how OpenAI does, how the tokenizer in OpenAI works. And you can go play with it in this URL in the slide. You can enter any text you want, and you can see how OpenAI would break up your text into tokens. So this is how they do it, but it's not necessarily how all tokens are done. So there's many ways to tokenize text. So let's think a little bit about it. You could, on one end of the spectrum, tokenize text by letter. This would be like the simplest way, right? So each letter could be a token. This would be good, except, it'd certainly be simple to implement, except you'd have a lot of tokens for a very short sentence. And these language models generally have a limit of how many tokens that they can take in. So it's not a very good idea to use more tokens than you need, right? So with that in mind, so why don't we do just the other extreme? Let's say each word could be a token. Well, that would be good because you could use less tokens for the same amount of text. But these models need to keep a list of all tokens that they consider. And as you can imagine, it's a little bit hard to keep a list of every word that exists, right? So for that reason, OpenAI settled on something in the middle. So each word is a few letters. And it seems like these days, most tokenizers that you see from other companies do something similar, even though they may have certain differences in how they're implemented. Okay, so now we know what a token is. Let's go back to our diagram, and let's now understand how language models work. So now you understand that they take n tokens in, meaning it could be a few words, it could be a sentence, a few paragraphs, a whole page. It really depends on the size of the model and how many tokens it supports. And then it produces 1 token out, meaning a word or a part of a word. Okay. It's pretty simple, but you may be thinking, well, I've worked with ChatGPT and I certainly don't just get 1 token out, right? You get a bunch of tokens out. You get a lot of text out. And that's because this idea gets applied in a sliding window kind of way. So you get n tokens in, you get 1 token out, and then that token out gets included in the tokens in for the next iteration. And then you get another token out, and you keep repeating this idea forward until you reach some stopping condition and your model is done. You're done generating the code that you wanted to generate. So that's basically why you get so much text out. You may also be thinking, so is this deterministic? So if I train a model and I give it the same sequence of tokens twice, do I get the same token out? And you don't. These models are actually not deterministic. And the reason why they're not is that actually there's one little piece that is additional to what I'm showing in the slide in how these models work, which is what they return is actually not a token out, but a probability distribution of all the tokens. So basically a distribution that assigns a certain probability to each possible token that it can generate. And so then you go and you sample from that distribution to get that token out. And the way you sample can be controlled with the temperature and the top P commands when you're using the playground in ChatGPT. Okay, so now This idea that I'm showing here, the tokens in, n tokens in, 1 token out, this is really just an idea. It's not an algorithm, right? There's no code. I'm not explaining code. It's an idea. And this idea has been implemented in many different ways throughout history. It's certainly not a new idea. So in the 70s, we had hidden Markov models, and I'm just going to call them HMMs. So HMMs are Markov processes, and the mathematical definition of a Markov process is that when it's generating a token out, it only looks at the token immediately before it. So that means, for example, if you input the quick brown fox jumps over the HMM is going to only be able to look at the. It's not going to look at anything that comes before it. So it's probably going to predict something like, I don't know, person or shoe or whatever, but it's probably not going to predict lazy, which is what you might expect. Then in the 90s, n-gram models came along, and they largely fixed this issue because you could actually input n tokens in. However, this n was pretty low, and so we were pretty limited in what we could do. And so then in the 2000s, neural networks came in and they became very popular, and they increased on the size of the number of tokens that you can pass into the model. And at the time, the neural networks that were popular were LSTMs and GRUs, which are types of RNNs. These neural networks had an issue, though, which was they could have exploding gradients or vanishing gradients, where the gradients of the model would actually become very large, like infinity, or go down to 0 when the network was too long. And when you had that issue, then you just couldn't train. The network just wouldn't learn. And so then in 2017, transformers came along, and they fixed a lot of issues. They increased the size of n that the model can take in. They fixed the stability issues, so the exploding gradients and vanishing gradients that the neural networks had. And they also introduced an algorithm that is parallelizable, so it works a lot better in the GPU. And transformers are based on this idea of attention, or the attention mechanism, which you may have heard about that. And so what this means is that the model is able to pay more attention to some inputs than others. So for example, in this sentence, she went to the store, and the model might predict bought. But to predict that verb, bought, the tense, the past tense of that verb comes from the second token, from went. So they both have to match. And so the model will be able to understand that and will probably pay more attention to the word went than it will to the word end, even though the word end is further back, is one of the first tokens that will come in. So this is kind of like the basic idea of attention. And transformers and attention, they're very important because they're still what is being used today in GPT models by OpenAI. So now let's look at the latest 3 models that OpenAI put out. So we have GPT 3.5, which they all use transformers. They all use transformers, and transformers they were introduced in 2017, as I said, in this paper called "Attention is All You Need," which was written by Google. And so then ChatGPT is based on the base model from GPT 3.5, and then it does a layer of fine-tuning on top of that. And so it fine-tunes that model with conversational data. And so why does it need to do that? Well, because 3.5 was really, it's a completion type model, which means that you type a few words, and then the model is able to generate words that come after, that are likely to come after. While ChatGPT is a model that is trained for conversations. So it has a little bit of a different pattern. And so then ChatGPT was also further trained with reinforcement learning with human feedback. And so the way that this algorithm works is the following. You give the LLM an input, and you get 2 different outputs back. And then you get a human that will rank those outputs, and then the ranking of the human will be fed back into the model, and the weights of the model will be changed to incorporate the human preference, basically. And this technique is based on this paper here that is, I just call it the InstructGPT paper, and that came out in 2022, and it was written by OpenAI. And then finally, the very latest model that is out, GPT-4, it's based on an entirely new base model, and it also uses reinforcement learning with human feedback. And if you see here, just below the titles, you'll see the names of the models that if you're using code or even the playground, these are the models that you would choose if you want to select each of these different types of models that OpenAI put out. And that's it for today. Thank you for watching.
So we're back in the studio, and Beatrice really clearly explained how these large language models work, but also the history of it. I really enjoyed it. What did you think of it, Willem?
Excellent overview.
Yeah.
There's so much literature about large language models that it's almost impossible to keep up. So this is one of the greatest resources so far that I've seen.
Yeah, I really think it's very clear. And also David did a great job by doing the more high-level overview, and she really did a deep dive into it. Really, really, really great.
Yeah.
So thank you so much for joining us here.
Thanks.
Can you please introduce yourself for a bit?
Yeah, so I'm Willem Meijns. I work as a Chief AI Architect for Agency, part of InfoSupport, a company that I've been working for 16 years now.
Oh.
I've been in the AI field for 11 years. Actually, one of the people that started with the global AI community. Yeah, I've been enjoying the ride so far. Since October last year, it's been super crazy with large language models.
Yeah. So you also worked in the, you also got that history into your daily work as well, with all those different language models that Bea just explained to us. You work with them as well, or not?
Yeah, I've worked with the smaller ones first, and the last 2 months, I believe, we've started experimenting with the really large models, GPT-4 even, although very short, so it's still a work in progress in that sense. Yeah.
And what are you specifically excited about in the AI field and what to come?
Ooh, yeah. So generative AI is one of those things that not a lot of people understand yet what you can do with it, and that's exciting, I think. Lots of people are learning about it. But the other thing that I find very exciting is productionalizing this sort of stuff in production. So MLOps is one of the key things that I work on, and combining that with large language models, for example, is super exciting to work on.
Nice, nice. So you're going to give a session. What is that about?
So I spent a couple of months working on a prototype for a chatbot using internal data from InfoSupport in an agency. I brought along a few snippets of code that I have, and one of the tools that I've been using is Microsoft Semantic kernel. So normal people in data science, well, normal, I don't know, data scientists often use Python these days. Semantic kernel is in C#, so it will be all in C# today. And that's on purpose, because I thought, well, if I can open up the world of large language models to C# developers, there's a lot more people there that can make use of this this sort of application.
Yeah.
And hopefully they will join in on the AI fun and eventually gateway over to Python. I don't know what happens, but it's a lot of fun
or
so
stay
far.
with C#. Yeah.
Yeah, that could happen too. Yeah, there's a lot of machine learning happening in C# as well these days. So.
Yeah. So are you ready then?
I'm ready.
Okay, let's go.
Let's take a look. Cool. So yeah,
We have to wait for a bit. Some technical issues, small technical issues. Yes.
Cool. So yeah, I brought along some stuff that I've been working on. It's very, very, very prototypical, if you will. That's all the stuff that's happening in large language models. So bear with me today as I show off some stuff that I've been working on. So yeah, the goal for me is to show you in 30 minutes approximately how you can use large language models from C# to enhance the functionality of your application. So large language models on themselves, like ChatGPT, are very useful, I think. But you can do a lot more once you start integrating large language models in your own application. So roughly, what are we talking about today? Let me first introduce Semantic Kernel to you, explain how it came to be, what is it exactly. Then we'll write some C# code, just to give you a feel of what you can do with C# in a large language model and what options there are. There's a lot of stuff to cover here. I'm not going to cover the full feature set of Semantic Kernel, just the basics today. But one of the things that I wanted to show to you is how can I use internal information from my organization with a large language model to give grounded responses. That's the stuff that they just covered in the previous sessions about the fact that large language models sometimes give you an answer that might not be actually true. And grounding the answers with information from a search index or some other location, that's very useful. And I'm going to show you how you can use cognitive search in this case. And then finally, I ran into a lot of challenges, a lot of things that don't work yet, as you might expect. That's all fine. And I have a few tips and tricks if we have time at the end to explain some of the challenges that you might run into and how to fix those. So I got interested into Microsoft Semantic Kernel and building on top of large language models from chat.openai.com, one of the most iconic samples of using ChatGPT in the world. I think many who are watching today have used chat.openai.com. But actually, if you look at the application, there's a lot more to it than just using the model, despite what you might think at first. So yeah, I tried to reverse engineer the architecture of what they made. And this is sort of the picture that I drew in my mind. So there's you, the user at the top, using chat.openai.com. You need a front end for the model to work with. And then you need some sort of application logic to control basically how input is handled, how output is generated back to the user. And that's the kernel, if you will, of the chatbot. Let's put it that way. And behind this API, there's the model, in orange in this case. And the model, all it does is generate the tokens based on input you provided to the bot. And I will show you in a minute how that works roughly. And then, of course, there's a lot of other stuff. I'm not going to cover that, but imagine that AI in this case is not just the model. AI is actually part of a larger application. And this is what you will see in many, many cases where we are using AI today. And I think this will get even more important towards the future as we build more AI applications based on Python or C# or another language. So yeah, talking about this kernel component, at the center of the application, there's sort of a key component that controls how the AI model is applied to language. Of course, on the left, it starts with a prompt. That's my message that I'm sending to the chatbot. It goes through the user interface to my API, and then it ends up in the kernel. And the kernel has a context that basically provides information. What should I do with this input? And this is what Microsoft Semantic Kernel implements for you. Microsoft Semantic Kernel implements the key component that you need for building large language model-based applications. And the way it works in Microsoft Semantic Kernel is that there's a context, and this context contains variables, the input from you, but also other information that you might need, like the name of the user, the location where the user is staying at, business information that you might need, maybe search documents. There's a lot of stuff you can include into your language application and feed to a language model. And the way you use a language model in this case is by building a skill. And the skill is made out of a prompt template, some configuration, and then a piece of code that you write. That's basically the core. And I'm going to show you in a minute how that works exactly. But you can do a lot more, because you can say, well, process my prompt and split it up into steps, for example. And then you can use something called a planner, and you can build plans based on language input that you provide. I'm not covering it today, but it's worthwhile to check out the documentation and learn about using a planner, because that makes it really powerful. And you can use this to build agents, semi-autonomous agents. The other important part here is the memory. So if you're using chat.openai.com, you don't have something called an internal memory. So business documentation is not included because it's not connected to your internal search index. It's not connected to SharePoint or other applications. If you want to use that, that's not possible through the public services at this point. What you need to do is you need to build your own chatbot. There's several options, but Semantic kernel allows you to do this in C#, and it allows you to connect a search index of some sort to the kernel to integrate search results into the chat conversation that you have. And I'm talking about chat at the moment, but since it's a large language model application, you can also use this for completions and other stuff. So, for example, you can categorize information, bank transactions based on a description. You can use it to generate project roles for a project proposal, and lots more stuff besides using it for chat. So that's enough talk about what it actually is. Let's take a look at some code and how to set up an application with it. What I'm doing is I'm building an application in C#. It's a console application, so very, very basic today. But you can integrate the same code into Microsoft Bot Framework or ASP.NET Core or Microsoft Teams, for that matter. That works too. I use this sample to keep it very basic, so you get the core of things, the kernel, if you will. So the way it works is that right now in my C# application, I've added one important package to the set, and that's the Microsoft.semantic kernel package. And the Microsoft.semantic kernel package is currently in preview, so you have to set the checkbox to include a pre-release. It changes several times per week at the moment, so it's moving very fast. So I recommend updating regularly because they are fixing stuff fast as well. This contains the core of what you need to build a language model application. And there are several add-ons based on the things that you can do, like custom planners, custom skills, connections to other services, so like cognitive search, Microsoft Graph API, for example, can also be used, that you can add to this collection of packages. And the idea is if you start building an application, you first have to build a kernel. And the way this works is by importing the Microsoft.semantic kernel namespace, you get access to the key component of Microsoft Semantic kernel. And to build a kernel, a very basic one would be kernel.builder, and then calling build. That will give you an empty kernel. But of course, we're building a language application, so I need to add a language model to it. In my example, I'm using Microsoft Azure OpenAI service that I've deployed in my subscription. And the way I access it is by giving it a name for my model that I've deployed inside my Microsoft Azure OpenAI, an endpoint, and a key, an API key. And that's how I hook up the language model to the kernel. And the way this looks in Azure is when I go to my Azure portal, I can open up the Azure OpenAI environment from the Azure portal. And what's important to keep in mind here is that here on the left, I've got several deployments in a collection. And the top one, the Da Vinci one, is the one that I'm using. So you can create a deployment for a model by selecting one from the drop-down. There's a load of models that you can choose from, giving it a name, and then making it available to the users of my application. A good thing to keep in mind here is that you can have one deployment per model. So if you're thinking, oh, I have a Da Vinci Text 3 deployed for one project and I'm going to deploy it for a second time for another project, that doesn't work. You can only use one, but you can use multiple Azure OpenAI instances for different projects. And it only matters for billing. It's not like you have a lot of options you can set at the moment, so it's pretty limited in that sense. Okay, so I've got this hooked up. What I then need to do is I need to tell it where to find skills. I just covered skills in my slides. A skill is a specific task that you ask from the model. And it's not that complicated, actually. Basically, what you do is you create a directory in your project with the name of the collection of skills that you want to use. And then you create a folder underneath that with the name of the skill. And just give it a descriptive name. It's something that you use from your code. That's the idea here. And what I need to do is I need to provide two files for it. The first file is my configuration file, and this controls the hyperparameters for the generation step of the model. In this case, I'm asking it for a completion. I added a subscription that's for debugging for myself. And then I said to Azure OpenAI, I have a completion skill, and I want a max 150 tokens back from the model. And the temperature is 0.7. Temperature controls how creative it is. So it controls the sampling of the output. As you might remember from the previous session, GPT generates a probability distribution, and we sample from this probability distribution the next token. And the temperature controls this sampling mechanism, the same as top P, presence, and frequency penalty. Those control how the output is sampled. So you might get more or less accurate responses based on these settings. So you might want to experiment. The other part of the skill is the prompt template. And the prompt template is actually a predefined piece of text that you write that gets filled in with variables from that contain the input from the application. So this is where you can control what the model is generating. In my case, I'm asking it, please explain what the following text is about. And then between curly braces and a $sign, I'm saying, put the input right here in the prompt. And at the end, I'm saying summary, colon, and that will generate a summary. I'm using summary, colon on purpose here, because if I don't do that, the model will start chatting with me. It will start telling me, sure, I can summarize the text, and I can, this is about blah, 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 a whole lot of text. In summary, this is a summary of the text. And that's a long story. I don't want that. I want it to be punctual. So I'm saying summary, colon, please give me the summary, and then stop talking to me. That's about it. And the way I can use this skill for my application is I need to give it a path where my skills are stored. And then what I can say is kernel.import semantic skill from a directory. And this directory is summarization. And that will give me the summarized text skill. And the summarized text skill, in this case, I can call with a set of context variables right here at the bottom of my code. And in the context, I'm putting input. Remember from my prompt text that I have here, there's a variable called input, so that gets filled up. And then what I do is I call run async on the kernel, and I will use my skill with the context information that I provided, and that will generate the result. So what I can do is I can run this on my computer, and I will start talking to ChatGPT, or rather the text completion model in this case, and I will start getting a response. And my input text was about semantic kernel, and I asked it, can you explain a little bit what semantic kernel is based on the text that I've provided? And it will generate a response. As you might have noticed, it takes a little bit of time. GPT models are not very fast, so this is also a tip already. Make sure that you provide a proper progress indication so users know that you're busy. Otherwise, yeah, they will get lost because it takes a lot of time to generate a response. So that's the basics of building a language model application. From here, it's all about creativity, building the right prompt, and all about controlling the temperature. But what if you have a more complex scenario? Well, what you could do, for example, is if you have a very large piece of text and you need to categorize it, it might not categorize it immediately in the correct direction. What you can do is then say to semantic kernel, hey, I want to summarize the text first, and then I want to categorize it. And the way you do this is by saying, okay, I've got this text here, run async, I have my input variables, I have my skill, I can chain a second skill, and I can say categorize. And this way, the input from one skill gets summarized and then sent off as input for the second skill. So you can build chains of skills if you want to. And this way you can build some pretty complicated pieces of tech in your application that allow for you to solve very complex scenarios. So that's the basics of Microsoft Semantic kernel. It's changing all the time, so my demo might be different tomorrow, but please give it a try. I will put it up on GitHub for people to take a look at. So there's one more piece that I wanted to show to you, and that's actually, I think, one of the superpowers of Microsoft Semantic kernel, and that's memory. We talked about this earlier in the session. You can build a semantic kernel skill to process text into a summary or categorize it, or even for chat if you want to. But that doesn't give you access to internal documentation from your organization. And this is where memory comes into play. What you can do is you can provide a memory to Microsoft Semantic kernel, and it will connect your business documents to your conversation that you have with the bot. And the way to do this is by using, for example, Azure Cognitive Services. So the way this works is, first we take the original prompt that we had before in the previous demo, and we send it to the kernel. We call run async. And what will happen is, instead of going to a skill directly, it will take the memory into account, and it will perform a search against cognitive search. And the output from the search gets included into your application. And once that's included in your context, you can send off the prompt template to Azure OpenAI with your search results included in that, and it will give you a much more grounded response in your application. So I can very quickly show that. I don't have running code for this right now, but there's a lot of samples on GitHub you can try. The way you include memory in Azure Cognitive Search is by going back to this kernel.builder statement at the top of my code, and I can say with memory, new cognitive search memory. And I can give it an endpoint and an API key, and it will connect up to my Azure Cognitive Search. And it gets included automatically, the memory, in my application. And of course, now you have to spend time dealing with search as well, on top of just writing a creative prompt and making sure that that works. But I can assure you it's really worth your time trying this out. I've had a great success finding information about myself in documents internally. So it's a very useful skill, I think. So far, I've been trying this for a couple of months, 1.5, 2 months approximately. And yeah, I've run into a number of challenges that I think are worth covering here. So one of the things that I ran into is that designing a good prompt is a very creative process. Funny enough, you can't ask an AI for a good prompt. It won't do that. You will have to write that yourself. And the first prompt will definitely not be the best prompt that you can think of. So the way I deal with it in my daily work is we start with a simple prompt at work, and we log the user response based on the prompt. We have a thumbs up, thumbs down button in the user interface. If a person presses the thumbs up button, we know this is a good prompt. If the person presses the thumbs down button, it's a bad prompt. And we look at the input that the user gave compared to the prompt and try to figure out a better way of doing things. This is the way it works in Semantic kernel. There are other options like Microsoft Prompt Flow that's just in preview, and you can use that as well if you have access at this point. They provide a lot of more options to deal with it. But if you're up for a challenge and if you're into software engineering, I can highly recommend trying out A/B testing for prompts and tracking the results in Azure Machine Learning Service, for example. just to get a better idea of how well we're doing. The other thing that caused a lot of issues, so to speak, is that, so I showed using chains of prompts and skills. And one of the things is that people often forget about is that if you have a chain of skills that generates multiple requests to Microsoft OpenAI service, and you're paying for all the tokens that you use. So be careful. If you have a lot of skills in a chain, you might want to think about combining those skills into one, writing a better prompt instead of chaining prompts together. Again, this is an iterative approach, so I don't know the full answer yet, how to do it. But yeah, it's worth spending a bit of time thinking about costs and how to optimize your prompts. The other thing is that, so you have the option of using a planner, and a planner allows you to combine API calls with large language model calls, with API calls, database calls. One of the things that happened to me is that my planner was running in a circle, and it was calling the language model over and over again for 15 minutes. And we were thinking, oh, he's doing a great job, but he's not doing a great job. He's spending all the money on your credit card. So be careful. This is not something you get protected against. You have to build your own code to protect your application against such things. And finally, yeah, this has been covered today many times. Safety is a concern still. I know that Azure OpenAI Service has protections against bad language and certain topics because they have a content moderation in front of it. But still, sometimes it just breaks. It's probability based, so we don't know what will happen. I would certainly recommend putting in place the necessary logging and monitoring stuff, and I would spend a lot of time actually testing the prompts in bulk just to make sure that you have the right prompt in place and all the safeguards are working as expected. Yeah, let's be honest, the problems that we had with a Bing bot that's generating a very evil response, that can happen to you too, because there's no protection, and you have to build that yourself. And that's it. I hope you enjoyed this, and if you have any questions, I'm still here, so you can ask them during the interview.
Well, Willem, thank you very much for this very interesting presentation. For me, it was quite new. I had not made use of Semantic kernel yet, but I think with these tips and tricks, for sure, I'm going to give it a try. Well, with that, we're going to our next guest. Hi, Alessandro.
Hi.
Have you made use of Semantic kernel already?
Not yet, but tomorrow I will use it.
Good idea. Please introduce yourself, Alessandro. Who are you?
Hi, everyone. I'm Alessandro Pagliaro. I'm a senior machine learning engineer working at ThoughtWorks in the Amsterdam office. I have a background in experimental physics, and today I will talk to you about how we use generative models to augment AI product development. And it's slightly different from what we've been talking about so far, because at the time we worked on this project, there were no large language models, so we have used other types of models.
So how long have you been working with generative AI then already?
A couple of years so far.
Before the big hype?
Yes, before it was cool.
Well, I'm looking forward to learn more about how you use generative AI without LLMs.
Thanks. Hello, everyone. I'm Alessandro. Hi, everyone. I'm Alessandro Pagliero, and today I will talk to you how we use the generative models without large language models to perform product development augmented by AI. I am a senior machine learning engineer, and I work for ThoughtWorks at the Dutch office in Amsterdam. ThoughtWorks is a global consulting company pioneering in the agile software development and working at the intersection between design, tech, and strategy. So applied data science as a natural fit in all this. It's a company with approximately 11,000 employees distributed in 18 different offices. And this year has been turning 30 years old. In the picture, there is me with some colleagues in the Amsterdam office, and our office in these old buildings with a little tower. Curious fact, this building was created in 1872, and it hosted the first farm factory in the Netherlands. So, again, product development. Let's start with an introduction about generative models as an overview. Generative models are a probabilistic model that can be used to as a way to create new data. You have some training data, you train a generative model, you sample from it, and here you go, you have new data. They have been developed since many decades. If you think about hidden Markov model or Gaussian mixture models. And there are several reasons why they are important. You can run simulations with them. I read they are used at CERN to simulate events for physics phenomenon happening in LHC collider. They are used to foster scientific discovery, for example, development of new drugs, chemicals, or new materials. There are plenty of applications for what concerns computer vision and NLP, so generation of new text and images, text-to-image, image denoising, or image compression. And last but not least, with generative models, you can generate new products, such as food and drinks. And this is what I will be focusing about in the rest of the presentation. This is the Intelligence, the world's first AI-generated whiskey. And this is how we started our journey with AI product development back in 2019, so way before I joined the company. And we have chosen it because it's a very representative example of what you can do with generative models. It's a story of whiskey distillery, a Swedish whiskey distillery, Mackmyra, which is located 200 kilometers north of Stockholm. And in occasion of their 20th anniversary, they wanted to do something special. So they reached out to us, and we accepted the challenge of supporting them in creating a new special recipe. So we use generative models fed with internal grades, consumer ratings, awards received. And with all this data, we were able to optimize the recipe generated. some of the recipes were shortlisted, and at some point the master blended selected one of those, and here is the result, which has been bottled. It has been a successful result because the first batch sold out in one day, and also from consumers' reviews, the AI whiskey scored way beyond the average for a whiskey base. But you might think that this is biased ratings because it's such a different product from the rest. However, in 2020, the Intelligence won first prize in a blind-tested industry competition. So it was clear that this was not only a success for the use of AI, but also in terms of taste. So after this introduction on generative models and a use case, let's make a step back and dig on the background of the product development. In order to apply AI for product development, it's essential that we understand how what's the work of the product developers about and which are the pain points. So the core tasks of product developers are essentially three. They might need to either create new recipes, so novelty, or change ingredients of an existing recipe. You can imagine you cannot use anymore a certain product, or there is some other type of change that you might want to apply to the formulation. And or the third task is that there might be a necessity to improve an already existing product. The challenges are that a lot of prototypes are produced, but out of those few are viable, so there is a low success rate. It is not always objective to choose out of all the prototypes which one to promote for production. And from the point of view of the data, there can be flaws in the way they are structured, because essentially there is not a structure, or they might be scattered in different places, so they are not collected just in one place. Last but not least, it takes time and efforts to upskill product developers, because there is a lot of difference between junior and senior in terms of skills. It is also important to have a clear understanding of how the product development flow is structured. Everything starts with a idea coming, for example, from marketing informations, from social, and then people from different departments gather and think about the concept of the product, the consumer target group. So at this point, the true development process can start. And this is a core phase which is characterized by a high degree of experimentation, because every prototype that is produced has to be tested by a panel across several round tables. There might be several interactions with the entities which are producing the ingredients. So it's the most definitely the most complex process. Once viable product, a viable recipe is reached, this candidate is promoted to the last stage of consumer testing, and then the product can be produced and commercialized. So this section in rose color is the one that can be augmented by AI. So we get to the point of really questioning how generative methods can be used to support product development. And the answer is that they can optimize the recipe so that the AI can be used as a sort of R&D assistant. And the design can be is showed in this diagram. So everything starts with the product developer, which is setting, for example, constraints on the ingredients or certain target to optimize. And then the generative model is starting to generate new recipes. The product developer will extract some of them out of a short list and literally produce samples that are tested by humans. This feedback, this scored recipe, are being used to feed the generative model, which is going to learn from these scores and with a explore exploit strategy is going to generate new recipes. So there is this iterative process where the generative models are combined to a feedback loop, and the generative models are used are sort of a gun. So there is a tandem of model which are interacting with each other. One model is generating new recipes, and the other model is rating this recipe. There are a certain number of iterations, and at some point, when there is no further improvement, the model generates a list which is used by the product developer to choose the candidates to produce. But it's not everything. A very important trait of the AI augmented product development is the fact that this is an augmentation and not a replacement of experts. So the product developers, the expert in this specific case, are those who will literally manage and inject, use their expertise to get the best out of the generative models. They will check the results. They might also participate in testing the recipe themselves. So it's really a combination of human expertise augmented with statistical learning superpowers. How is this approach perceived? This is an example of feedback from the master blender of McMurra, which stated, we see AI as a part of our digital development, and it's really exciting to let AI be a complement to the craft of producing a high quality whiskey. So it's a perfect way to leverage, as said, the human expertise together with capabilities produced by new technologies. Human expertise, which is really specialized. I was surprised by the title, but actually chief nose officer as a meaning and importance in this context, because this type of development does not only require to have a background in a specialized discipline such as biology or nutrition, but also a very well-developed olfactory sense. So we talked about the generative models from a very general perspective, about the product development and the approach that we have used to combine AI with product development. And now it's the moment to talk more in details about the benefits and the aspects to consider in order to be successful in adopting this approach. Benefits are can be over different types of angles. Benefits in terms of the techniques, benefits in terms of the usage, and benefits in terms of the process. From the point of view of the technique, a peculiarity of this approach is that it can learn from small data. It can also learn from no data, because sometimes it happens that when we start an engagement with a client, there are no usable data. So some of the first iteration has to be used to calibrate, initialize the system. Second benefit is that it has a very efficient way of experimenting and exploring compared to traditional methods such as design of experiment, which means that there are tangible business outcomes because you can bring a large amount of products to the market faster. And when I say exploration, I mean that there is this very large design or search space composed by tens of ingredients, sensory attributes, and it's a very challenging task to navigate and optimize through this big space. From a human perspective, this is an approach with a human in the loop, so that the product developers or the expert of the specific fields are on the drive seat. They are the one managing this system. They are not in a passive position. This approach fostered the collective knowledge sharing among the experts, so that it is easier to upskill more junior team members, and also helps in having a more structured process to harmonize the data and collect them in just one place. So benefits are not only on the output of the recipe, but can also be on the way of working, on the process itself. From a system perspective, a very big point of this approach is that is not a point solution, but is something that can be reused to develop different types of products, and can be easily scaled because the system design is rather simple. And last but not least, as I mentioned earlier, the product developers have to deal with a very large space, ingredients, sensory attributes, maybe multiple parameters to optimize. Think about consumer liking or cost or other parameters. So it removes from them the hard task to manage this complexity. There are, although, aspects to consider to be successful with the adoption of this technique. The first one is that the feedback loop need to be thought in terms of the time it takes to get feedback from testing panel of experts or from laboratory instruments. And also, it's important to consider how much every one of these measures costs, so that these can adapt the available time and money budget from the company that wants to pursue this type of development. And also, the dimensionality of the problem is an aspect to be careful about, because intuitively you can understand that the larger the amount of dimensions, the more the time it will take to get to a viable product, and the more the time it will take to for the generative algorithm to return an output. Now, let's try to abstract away from the specific use case that I mentioned of the food and drink industry, and let's think if there is some other way we could use this approach for product development. So not only for optimizing a recipe and receiving measurements from as I said, testing panel or from laboratory instruments, but we could think to use it and to extend it to develop a generic kind of product. It might be optimizing drugs, chemicals, or new materials, so that instead of a recipe, we think about formulation. So an ensemble of components, and the feedback generated by whatever the specific laboratory or industry can use to provide an evaluation. So again, it could be people or instruments from a laboratory. And reach the point where we can summarize what we have seen so far. So generative models are very useful because they can be used as a tool to simulate new data. They can be used to solve a real-world problem, complex problem, such as development of whiskey, or you can see in our website example of how we optimize the taste of Oreo cookies. They can also complement and enhance the expert capabilities. So they are not used as a replacement, but as an additional tool that can support the experts. And there are potential to generalize and extend the way AI is augmented product development. Thanks for listening.
Well, Alessandro, thank you very much for this different thought on generative AI. It's of as I said, different compared to what we're looking at these days at all the GPT models, the llama, the bird, and so on. But we're here together with all the other people who already had a session, but also with Alona. Hi, Alona. Could you please introduce yourself for the people who are watching?
Yeah, hey, welcome everyone. I'm Alona Gareva, Microsoft AI MVP, running PyDatis Amsterdam and working for Thoughtworks as a principal machine learning engineer.
Okay, thank you. Well, I've prepared a couple of questions that we can discuss just now. And the first one is we've heard a lot about copilots, building chatbots with the GPT models. What other kinds of use cases have you been working on? Maybe I'll start with Alona.
Oh, that's actually a lot. We're not allowed to say a lot about that, but at least from what we're experimenting with, there are a lot of promising stuff, but also there are still a lot of let's say guidelines which you need to implement, because otherwise it's a little bit, I would say, oversold and overhyped. Like, oh, this is a beautiful box, you just input text or whatever you want, any information that you have, and just output a perfectly structured information from you. It is, but it is not to a specific extent. So I would say now the majority of the use cases that we are working with is just experimenting, try out small things, running small use cases, especially for the highly regulated industries, which is pretty dangerous to release it as it is. So we need to pass a lot of compliance meetings and everything. And for this kind of folks, it's completely something new and they don't understand how it works. And also it's accepting that it's not 100% true output that you can easily test. So it's not something that, could be easily testable. And sometimes it could generate really strange ideas, so really strange things. So you need to be prepared for literally mitigating it.
Thank you. And for you, any specific use cases in mind?
A very practical use cases we were considering is, for example, to use large language model capabilities to perform more efficiently some data processing tasks. So especially, say, when you work, and this happens quite frequently with unstructured data. It is very useful if you can summarize the content and gave it a specific format and, for example, output it in a JSON. That could save a lot of time and increase the quality of the data that you can use to feed whatever model later on.
You, Willem? Anything you've been working on lately you can share?
Yeah, as with the others, not a lot of concrete cases. There's one interesting use case that we are working on is actually using the embeddings generated for OpenAI. And we use that to collect clusterings of people that are answering questions in questionnaires. So we have a million people filling out questionnaires the whole day. And we generate embeddings from the answers, and then we cluster those together to generate a persona. So we're not interested in the real person, we're interested in what sort of person is represented. And that's where the embedding part of the model is more interesting than the model itself, actually. So that's quite fun. And the other thing is, for us internally, we write a lot of project proposals. And we're trying to automate part of it using a large language model. But it's mostly trying at the moment, so it might not work in the end. Yeah, lots of fun stuff happening.
It's all quite new, so it's still up to developers to figure out what can we build, of course.
Yeah.
But now all these use cases are mostly concerning text generation. We also have many different kinds of other models that generate actually pictures or photo, even really photorealistic things. For example, DALL-E. Have you been working with this already at customer sites, or do you see specific use cases that are very handy?
We haven't actually used DALL-E yet. We had a use case at the beginning of this year where we were classifying container codes, shipping container codes. We didn't have a lot of training data to work with. So what we did is we actually generated more images to train the model on. So we started with a sample of 2,500 images, and we ended up with 5.3 million after the computer was done. Is it perfect? No, by no means perfect, but at least it alleviates the pressure on people gathering data. We didn't have a lot of people running around the world taking pictures of shipping containers for some reason, and this was a perfect substitute and a lot cheaper to do.
Quite a very interesting use case. Never thought about the usage of image generation that way.
Yeah.
Nice. Yolanda?
I was just listening. It's like how we were working on the same project. Because in my case, then it was further distilled to the moment when you need to literally perform OKR on top of to recognize the number of the container the number of the container, which comes with a lot of other challenges because you have the number of containers that's written horizontal way, but you also have the numbers that's written in vertical way, while text is preserved not in vertical way, it's not rotated, it's preserved in this way. And there are a really limited amount of text models before that were capable of doing this. It was mostly designed for Japanese and Chinese language, as you can imagine, and Korean language. And it was pretty bad in comparison with normal, let's say horizontal text. But getting back to pictures, a lot of, so we're using a couple of projects using Stable Diffusion at the core. And what we're doing, it's literally a treasure trove for textile companies that producing literally visuals for their websites, for example, for their product lines. Also to reduce the waste, so you don't need to produce a lot of samples of, for example, clothes pieces. You can just literally generate them and then leverage it and give it to designers to play around with 3D and everything, how it looks like, what the structure of this, let's say, cloth, whatever. In addition to that is, again, reducing the amount of money that has to be spent on different photo sessions, because as you know, we're all talking about personalization for the consumers. And for a lot of consumers, it's not enough just to have one picture of the person just standing like this. You want to see the person in action, the person which wearing this clothes or shoes, performing some specific like jumps or whatever. It's also helped a lot. We were generating synthetic data. We're also generating literally pictures for the website. That's basically what it was. And it's also helped us to enhance the visual search capabilities we were building, because for creation of visual search is pretty like complex task as well. Again, that requires a lot of synthetic data, and sometimes this data is really hard to get. So by generating the data and then training another model on top of this data, we were managed to achieve, let's say, the level of productivity that you could never imagine about. And I think the third case is for game industry, because when you develop a game, I'm talking about like games like PC4, you know, they're like, or sorry, PC5 now, or like Xbox, whatever. So a lot of time and money should be spent on creation on NPC, recording voice, recording, let's say, creating the way how this person gonna look like. And with this fantastic capabilities, now it's again speed ups the cycle of development, and it's reduce as well as carbon footprint, because you don't burn so much compute as you have to burn before. You burn it still, but in a limited amount of time, I would say, in a specific sequence. So yeah, and I think there are much more to that, but these 3 use cases were the most powerful.
For you, Alessandra?
I'm a bit biased here because I don't work with images at work, but a lot of the people that I know outside work are either front-end developer or designers or architects. So when I hear about the capabilities provided by generative AI in terms of images, I think straight away to a possibility for these categories of people to experiment quicker and have a great source of inspiration for new front-end layout or website designs or rendering of building. So this type of applications.
Yeah, but I think if you link it back to the text, there's more use cases at the moment going on with text than with the image, right?
Yeah, I think that's due to ChatGPT being released and people all of a sudden became awake and say, oh, this is interesting. I can talk to my computer and it talks back. And it seems intelligent also. And that's, yeah, it's mostly, there's a lot of hype. I'm going to be honest and say, well, I hope that dies down a little bit, get to a normal proportion, and people start to learn more use case beyond the text use case. But I think that will happen.
Yeah, the funny thing is DALL-E was released before ChatGPT even. So think it was 2020 already when the first
Yeah,
DALI
the
models
first
Yeah,
were
the
one.
first
released.
version. Yeah,
Yeah.
yeah.
Well, I think if we also look at how Photoshop is integrating these kinds of models to help editors to be able to edit pictures or extend the background or remove people from pictures, it's quite
It's
magnificent, right?
insane. Yeah.
Yeah, it's absolutely insane what you can do now. And I don't think Photoshop would have received as much as attention when ChatGPT didn't happen.
That's true, because at the end it's still a combination also of natural language combined with picture or video editing.
Yeah, we shouldn't forget that there's a lot of pre-processing and post-processing happening around those models. So the fact that Photoshop was able to build content-aware fill and neural filters, that happens because they have a long history of knowledge about manipulating pixels on screen. And now they start adding AI and it gets even better. Yeah, it's pretty cool.
Well, if you go back to text, Willem, your session about semantic kernel, we also have LangChain. Could you give us maybe a comparison? What?
Yeah. Is there a comparison? So the thing is, since it's so super popular, people have started building frameworks like crazy. So LangChain and semantic kernel are both well known at the moment, but that might change. And there's not a lot of difference between the frameworks actually. You can build the same applications with both LangChain and semantic kernel. The big difference, I think, for .NET developers and Microsoft-minded people is that you can use semantic kernel from C#. And you can't do that in LangChain. And but as time progresses, I think Java will join in on the fray as well, and we will have a replacement for LangChain and semantic kernel. I'm pretty sure. There's also an effort, people building graphical tools to build prompt chains. Building a single prompt is hard still, but it looks easy. But as soon as you enter the space where you have to build chains, then it becomes very complicated. And I think it's nice to see that there are better tools being built at the moment.
Why would someone make use of one of these frameworks instead of just consuming the OpenAI libraries by itself?
Oh, that's a good question. Yeah, so if you go up to chat.openai.com, you basically enter a chat application. It's already made. And if you start entering prompts that are not chat related, it might not respond in the correct way because behind the scenes, it received an initial prompt. It received some instructions from OpenAI. Hey, you're a friendly chatbot. You're going to answer questions. Oh, please don't talk about these topics and don't reveal that you have a couple of secrets that we put into your model. That might, I mean, if you're chatting, that doesn't interfere. But if you're building another application that has to do another task, then that will probably interfere, but we don't know how much. So if you want to start with a clean slate, I highly suggest building an application from scratch almost, but based on the model itself, rather than using something like chat.openai.com.
Anyone thoughts on this?
We have done some internal project using LangChain, where, as we said before, it's an important time this to experimenting and testing the limits. So we have used, we wanted to build a document-based question and answer chatbot using ChatGPT and building some semantic layer. And for this, we used LangChain to feed the data extracted from internal non-sensitive documents and store it in a vector database and use it in combination with OpenAI to build this chatbot. So it was a rather quick experiment to run. So we were surprised by how easy it is to be able to get something up and running.
Okay, thank you. Well, if we go back to some discussions that were done in the keynote, one was about copywriting and regulation. And if we think back a couple of months, or is it 2 months or 1 month, I don't exactly remember again, there was some group of people who wanted to pause all AI development for 6 months.
Research. Yeah. Oh,
Research, exactly,
Yeah.
exactly. More correct. How do you personally feel about that, Alona?
Yeah, I have mixed feelings about that. So first, let's focus on the second part. So to stop AI research, I think it doesn't make any sense to stop AI research because it's not the AI research that do something wrong with the world. It's just how we as people use it. It's just a tool and the way how we use it. First part, especially working a lot with images, it's really, really, I would say, unclear ground because by default you're not allowed to scrape stuff from the internet. It's by default, but you know how it works. So the majority of images were of course scrapped, and you can see it back when you recreate the training samples. You can see the blurred, let's say misformed, for example, logo of Getty Images and all of that. So that's hard part of the story. So whereas still, I do hope there are more attention will be put in this field. So what is let's say, allowed to be scrapped, what is not. Then also, like to answer the questions, if I generated something based on the work of two big artists, could I put my name on it, or should I pay royalties to someone for using that? There are a lot of, let's say, ethical questions that could be sorted out. But I think we right now in the right direction because the more and more voices popping up and the more and more things we start discussing. But although it's a very tricky ground because you don't know to whom to attribute let's say, the creation point. That's, I would say, the hardest one. And another thing, imagine, for example, getting back to the story of e-commerce platform and images. You want to generate clothes, you want to change the clothes, how it looks like, but you do not prefer that it's gonna grab the brand's logos of other producers and place it on top of your clothes. That's something that you want to prevent of happening. So that's why there are a lot of things, there are a lot of moving pieces, I would say. But to cut the long story short, there are a lot of work that has to be done about how we scrape. Do we give permission to use this data? Do we give permission to use our photos from social media? Do we give permission to use our videos on YouTube to use as a training data as an input? That's the big question, I would say.
In my opinion, it's very a bit utopic to say that you can stop or not, because it's not you press a button and it stops. So research and advances are done by different organization entities. There are the big companies, there are open source community, there are individual researchers, there are universities, and it's difficult to stop this flow. I think it's a more a responsible and pragmatic way to deal with all the side effects is to experiment and acknowledge and be mindful, making sure there are all the safety nets or discussions. So I think it's better to have a sense of awareness and create communities and talk about so that everybody can be more aware, because it's inevitable that this is a so disruptive technology. I cannot remember any other product that became so popular and generated so much adoption and discussion.
Yeah, totally agree with you. It's so changing the world that, but I think therefore it might be important, instead of saying 6 months pause, let us say, okay, let's do 6 months focusing on how to use it in a responsible way.
Yeah.
And if you focus on that, well, then more things will follow out, and because of people being able to start making use of it more, they will also figure out what's going wrong. Based on that, indeed, enhance the product. Right? Okay. I think linked to that also, I think the big problem also is that people do not always understand what those models do. Do you think, how can we help people educating on this?
Yeah, we're already spending a lot of time educating people, of course. Global AI community is doing this for a large part. Local communities are also very important, I think. For example, I spent a couple of days a few weeks ago at local universities, but also lower education. People who are working with their hands, building stuff, commercial services, people behind the desk, the help desk, for example. explaining each on their own level what AI means to them. And sometimes you have to explain the mathematics behind it. If I'm at a local university, that's the level. But sometimes it's just, how can you use this in a positive way? And that really helps, I think. I got a lot of positive feedback on the fact that we focused on the positive things. For example, translating a very complicated letter from the local municipality explaining to you that you shouldn't put trash next to the trash can outside, which was a page-long letter explaining that it was wrong according to some laws and subsections, etc. And I showed to them, this is what you can do with ChatGPT. You can ask it to explain it to a 5-year-old. Of course, you're not 5 years old, but yeah, it's still useful. I think that sort of education is very important. And check, double check. That's always what we teach to everyone. I think that's beyond AI, critical thinking is the best skill to have right now, I think.
Any thoughts, Alona, on this?
Yeah, I just want to add, so usually during, let's say, my everyday, let's say, agenda, I need to explain AI to different levels of people, the different responsibilities pools as well. And the thing which is pretty hard to do is to explain to the people who are already oversold with these capabilities and possibilities, to explain it's not a search engine. So sorry to say that, but if you guess that you never pay any attention to how the data were stored, how the data were transformed as your company, how data were used as your company, let's say what the sensitivity levels of this data. And if you just throw it, to the ChatGPT and then it's gonna figure out on your own, then will be capable of finding everything. Unfortunately, it doesn't work this way. You can use it at the layer on top to enhance this capability, but it's not replace the solid search work that was done before, let's say, for many, many years. And I think sometimes also showing by doing. So for example, that's you mentioned with local communities, and also doing the same, and just explaining the limitations and showing, for example, like good example, if we're talking about context again, getting back to ChatGPT, hallucinations, that's exactly, if you make people aware of it, it's not a search engine, it's not a knowledge graph, it's just this interface that tries to predict the closest possible answer, taking this word context. That's what it's capable of, although it can produce stuff that looks really appealing, it looks really, let's say, like future-proof. Unfortunately, it's not. And by just step by step, indeed, educating, giving this session and showing, look, these are possibilities, that's fantastic, but look at that part, that's also like limitations of it. So I think that's the making point.
Well, I think it's not a problem, but it creates a problem, is that implementing these models are quite easy to do. So you don't need to have advanced master skills to build a small chatbot already. And if you don't know how to fine-tune these models, then you create problems, of course.
Yeah, it's deceptively easy because the first step is really simple. You enter text and you get a reply that looks reasonable. But then somebody else changes one word in the input, and then it breaks all of a sudden. And then the question is why? Why did that happen? And we don't know, not yet at least. And I think that's part of the challenge that we have. So we need a mix of people who are writing prompts using the model from a very basic perspective, trying things out. Oh, it might be useful to use it for this, and then have proper support from data scientists, people with more knowledge about the internals, to support them in their journey and make it better.
All right. One more last question. Well, just the last question, not one more last. And it's a question we almost ask everyone. What's next? Alessandro, what do you think?
I was watching a video from Jan LeCun about transition from machine learning to systems that have more cognitive capacities. So I think there is a lot of effort being done in this sense by all the community interested, for example, in the causality aspect of statistical learning systems. And also, I think a lot of development for all what concerns the MLOps part of this large language model, because now we are in the stage where we are experimenting, but at some point it will be the case to more and more frequently deployment. So you need to take care of monitoring, of reproducibility, of compliance, and so this is also something that deserves a special attention.
Yeah. So a very interesting one, the version control of, for example, the prompts. Yeah. Alona?
Yeah, I think two things for me. One is to making it accessible for the more and more diverse and inclusive society. So to make sure that it's not only like the typical developer do these things and that's limited by power of imagination of this person, but also other folks who can challenge it and see it from different perspective and what kind of things we can do with it, how we could enhance the life of people with specific disabilities, for example, what we can do about that. And second is never underestimate the power of open source communities. So we're really happy to see as soon as, let's say, these proprietary closed models were released and get popularity, then immediately like it started popping up like Llama, then Falcon. And I think it's more things to come. And even, let's say, again, inviting more folks into joining this open source community and make it challenge and make it open for discussions for everyone. That's probably what's going to lead to more, I would say, better and safer future. From my perspective.
I think it was someone at Google who said we don't need to be scared of the big cloud vendors, but most scared of open source world that would probably create better large language models than all the rest.
And it's already happening. And they get smaller. So I think that that's another one that people should look out for. So climate change is real. And we're noticing it more and more. And in the meantime, we're building these models that are so large that you need a full data center to run it. That's sort of going in a weird direction. I wouldn't say necessarily wrong in the sense that, yes, of course, that will change. But the focus of open source on building smaller models that are more powerful, I think is a great, great step to see here. And we should definitely focus on trying to build models that are CO2 efficient. If we have to spend the CO2, let's make good use of it instead of blowing it all on a bad model in that sense. Yeah.
Okay. Any last thoughts about generative AI?
Well, I'm so looking forward to the next weeks.
I think it was during one of the build sessions, they said, of course, we're not in an AI winter anymore, but in a serious spring break festival with everything that is coming out. All right.
Indeed.
Thank you all for joining us today here at the Global AI Studios. We're grateful for having you and share your thoughts about generative AI. And with that, I thank you all for watching this online, live, or on demand later on YouTube. Bye-bye.